Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. I am so excited to be here with you on this day before July 4th. So welcome. Like Dr. A said, I am one of the math specialists here at the Learning Liaisons, and I absolutely love what I get to do here, which is help you feel more comfortable with passing your certification exams, with helping you feel more confident in those math problems that we're going to be solving today. So sit back, get your pencil. Like Dr. A said, we are here to have fun together. I'm just trying to find my PowerPoint so that we can get started. We are here to have fun together. It's a non-judgmental zone, so don't hesitate to ask questions in the comment box because that's what we're here for. Don't hesitate to ask those questions because that is what we are here for. So before we get started, I always like to do a get to know you. So in the comment box, let me know where you're from, what test are you prepping for, and what kind of holiday traditions do you guys have for July 4th? Do you like to go watch fireworks in like a big crowd? Do you like to go to your little local city fireworks display? Do you put off fireworks at your own home? Do you do sparklers and a barbecue? Like, what do you and your family do? We don't really have any traditions per se. I would say we just kind of go with the flow each year. I am obsessed with fireworks. I love them. It's a huge part of my story for another day because right now is not like, story time. It's math time. But I am obsessed with fireworks. So I love to go see them. We haven't been in a couple of years because COVID, and then we had a baby, and fireworks are so late, and the baby doesn't stay up that late. So we are almost out of that phase where we'll be able to go see fireworks again, but right now it's just not the time. So we will probably just do a barbecue at a friend's house and enjoy that and enjoy like the sparklers and all of that, and that's about it. So given that today is right before a holiday, we are going to have a little bit shorter of a session today, and I'm going to draw some fireworks on our screen for the holiday. We're going to do a little bit shorter session today just because we still have a couple of things we need to do before we do the whole barbecue thing tomorrow. But other than that, we are going to go over some problems. Here are my lovely red, white, and blue fireworks, and I'm repping my patriotic scarf. I wore it to work today, and I learned that technically Treason Day is yesterday, which is Independence Day. We celebrate on July 4th because that's when everything was signed, but I learned that. Fun little social studies tidbit for you. So if you requested some problems last week, I do have them in the works. There were so many requests last week, which is amazing. It actually makes my job more fun when requests are made because I get to cater to like what you want. But that said, it just means that we have a backlog. So if you haven't joined us before, I always like to do a what do you want to see in the upcoming weeks? And I had so many requests on our Facebook page and in our session last week that I'm just a little bit backlogged. So just join us in the next couple of weeks and you will see your request show up. I promise. If you're not sure if I got your request or not, don't hesitate to just throw it in the comments again as we're working today. So this is my little next week section. I don't know why I put notes. Next week. So if there is something that you want to see me go over in the upcoming weeks, remember I'm backlogged, so it might be a couple weeks. Please don't hesitate to ask. That is why we're here. That is why I'm here. I love to help you with the stuff that you need help with. Like, you know, if you don't need help with linear equations, why do we need to go over linear equations, right? And there was a lot of people that commented like specific problems and photos, which is, I love that. So let's go ahead and get started. Problem number 1. The first 2 problems tonight are very foundational. They're for my K through 3, K through 6 people, but my intermediate people, my middle school and high school people, you have to know this information or the building blocks are going to crumble, right? So you still have to know this. Which of the following shapes does not have to have 2 pairs of parallel sides? Which of the following shapes does not have to have 2 pairs of parallel sides? So when we look at this, we have our parallelogram, our rhombus, our rectangle, and our trapezoid. And when we think about the definition of these, we're trying to figure out which does not have to have 2 pairs of parallel sides. When I think about the definition of a parallelogram, the definition of a parallelogram is 2 pairs of congruent parallel sides. And like your quintessential parallelogram is going to look something like this. It looks like a pushed over rectangle. Now, that is a parallelogram that is nothing else, just a parallelogram. However, when we go into what is a rhombus is, and I'm copying and pasting this because it's a parallelogram. I don't know why that feature is not working. It's a parallelogram that also has, so plus 4 equal sides. So the quintessential rhombus looks like a pushed over square. Okay. So far, we only have shapes that have 2 pairs of parallel sides, right? A rectangle also has 2 pairs of congruent parallel sides with 90-degree angles. There's my rectangle. So far, we have 2 pairs of congruent parallel sides. However, A trapezoid does not have to have two pairs of congruent parallel sides. A trapezoid has to have at least one pair of congruent. No, not congruent. I'm sorry. I was in like a pattern, one pair of parallel sides that are not congruent. So the typical trapezoid that you and I think of looks like this, where this side and this side are parallel. But this is also a trapezoid because this side and this side are parallel. But now the state of Florida has expanded that definition to, it used to be exactly one pair of parallel sides. So these were your only two trapezoids. But now it's at least one pair of parallel sides, which means your rectangle, your rhombus, and your parallelogram are also classified as trapezoids because they all at least have one set of parallel sides. However, the question asked, which of the following shapes does not have to have? It doesn't say does not have, it says it doesn't have to have. Now, keep in mind, each state has not necessarily jumped on the trapezoid bandwagon. Hey, my dog is scared of thunder in my bed, but he's like licking his paw, and do not lick your paw in my bed. That's gross. So you have to make sure that you understand your test's definition of trapezoid. And if you're not sure, please reach out to me and I'm happy to tell you specifically which test, because each state and each test have adopted a different definition of a trapezoid, which is so frustrating, but it is what it is. Eventually, we'll all get on the same page as to what a trapezoid is. All right, let's move on to problem number 2. Which of the following best describes the faces of the following figure? Which of the following best describes the faces of the following figure? 2 equilateral triangles, 1 square, 2 rectangles. 2 isosceles triangles, 1 square, 2 rectangles. 2 equilateral triangles and 3 rectangles, or 2 isosceles triangles and 3 rectangles. All right, so in order to be able to solve this problem, we have to be able to understand the vocabulary behind this problem, right? And so if I don't know what equilateral, isosceles, and isosceles mean, if I don't know what a square versus a rectangle is, if I don't know what a triangle is, those are all very critical pieces of vocabulary in this problem. If you know your vocabulary, this is a 20-second question. If you don't know your vocabulary, this could take you 4 to 5 minutes because you're going to sit, you're going to read it, you're going to get frustrated because you don't know the vocabulary, you're going to stare off into space. Like, that's just what happens, right? We just get frustrated. We're like, maybe I can figure it out. If you know the vocabulary, this takes no time at all. So let's pause and go over the vocabulary. A square has equal sides, right? And 90-degree angles. And it's 4 sides. A rectangle, we already went over on the other slide, has 4 sides, they're parallel, and 90-degree angles. Okay, we should all pretty much know that. But the difference between isosceles, scalene, and equilateral. An isosceles triangle has 2 equal sides. An equilateral triangle has 3 equal sides. All the sides are the same, hence the name equilateral. And a scalene triangle has no equal sides. Now, scalene wasn't on here, but I figured since I'm doing a vocabulary review, I'm just going to review it all, right? So when I look at this diagram, I see that I have a rectangle here. And I see that I have a triangle here. And there is some critical information about this triangle. They've told me that this side is the same size as this side. That's what those little tick marks mean. Those little tick marks are congruency symbols, which means they are the same size. But this does not have the same congruency symbol, which tells me automatically it is not an equilateral triangle. It is not an equilateral triangle. So I know I'm dealing with an isosceles triangle. Now, do I have one square and two rectangles, or do I have three rectangles? I am absolutely going to have three rectangles. I do not know the length of X and Y. And because of that, I know that this is going to be three rectangles. I can't prove that there's going to be a square. How do I know there's even three rectangles? Well, when I have a prism, and this is a triangular prism, I have two bases that are triangles, and then they are connected by rectangles. So I have that yellow rectangle on the front. I have this pink rectangle on the back. And I have this blue rectangle on the bottom. If you're not sure how many rectangles there are surrounding this prism, there are the same number of rectangles as there are sides on my base. So my base is a triangle because this is a triangular prism. And because a triangle has three sides, I'm going to have three rectangles connecting my two triangles. Does that make sense? Awesome. Let's go ahead and go on to the next problem. Which of the following is the third coefficient of the binomial x minus 2y to the sixth power when it is expanded and written in simplest form? Whoo! Which of the following is the third coefficient of the binomial x minus 2y to the sixth power when it is expanded and written in simplest form? Okay, this is definitely for my high school people. This was a specific problem requested on social media. It wasn't this exact problem. I tweaked and changed and made it my own. But often it will say, which of the following is the first coefficient? Which of the following is the third coefficient? Which of the following is the expanded version of this binomial? Yes, we could multiply it out. Note, this does not mean x to the sixth power minus 12y to the sixth power. Nor does it mean x to the sixth power minus 2y to the sixth power. We do not distribute exponents. Exponents do not distribute. What we have to do here is recognize that an exponent means, this is for everybody, primary people, kindergarten through sixth grade people, you need to know what an exponent means, even though this isn't your problem. An exponent means take that thing and multiply it that many times. So if I have 4 to the third power, that is not 4 times 3. That is 4 to the third power equals 4 times 4 times 4. So this means x minus 2y times x minus 2y times x minus 2y 6 times. That's a lot of times. That's a lot of times. That's what it means right there. That is not the same as x to the sixth minus 2y to the sixth, is it? So could I FOIL this out? Yes. I could sit here and do x times 2y, 2y times x, 2y times 2y, and get an answer. And then take that and multiply that times x minus 2y, and then take that and multiply that. That takes so long, y'all. That takes so long. So understanding Pascal's triangle and binomial expansion is super duper critical here. Let me tell you, when I was in high school, I did not understand the purpose of Pascal's triangle. When I was in high school, I didn't understand how much of a shortcut it would provide me. Now that I'm an adult teaching this, it's huge. So Pascal's triangle looks like this. 1 at the top and a 1 and a 1. So you're going to create a little triangle with a bunch of 1s. Then on the outside are always 1s. So there's always a 1 on the outside. And I'm going to add these two things together too. You don't have to memorize Pascal's triangle. Then on the outside are 1s. Then I'm going to add these two and add these two. Then I'm going to do 1s. And I'm going to add these two and these two and these two. Then I'm going to have some 1s. And I'm going to add these two and these two and these two and these two with a 1. Do you see the pattern? Now, this is the 0th row. This is the first power, the second power, the third power, the fourth power, the fifth power. We still haven't gotten to the 6th power yet, so I have to do one more row. 1s on the outside. Add, 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 add. 6, 15, 20, 15, 6. You're like, what does that even mean? It means I'm going to expand this. So when I do binomial expansion, the first term, and I'm going to have 1, 2, 3, 4, 5, 6, 7 terms. So I'm going to actually erase this and make sure I have enough room, right? So I'm going to have 1, 2, 3, 4, 5, 6, 7 terms, but imagine they're all in one row, right? And I'm going to have, in the first one, I'm going to have 1 times x to the 6th power, 2y to the 0 power. You're going to see the pattern here in a minute. Then in the next box, I'm going to have 6 times x to the something power, 2y to the something power. We're going to do the powers in a minute. Then I'm going to have 15 x to the something power, 2y to the something power. Then I'm going to have 20 x to the something power, 2y to the something power. You see where I'm going with it. Now, not all of these are necessary because they only asked me for the 3rd coefficient. So I only need to do this one. How cool is that? This is why Pascal's triangle is so amazing. Now, the powers, those are important. The powers go like this. The first guy gets a 6, and then it goes 5, 4, 3, 2, 1, 0, and it disappears. Then the second term goes 0, 1, 2, 3, 4, 5, 6. Now, what I forgot was the negative. The negative is important when we have odd exponents, because you and I both know when I do negative 2y times negative 2y times negative 2y, I'm going to get a positive here because a negative times a negative is a positive, but then I'm going to get another negative here, right? So that negative is important because it does exist here. Now, I am only going to evaluate the 3rd term. Now, when I was actually creating and solving this problem, I literally didn't write any of this down because I knew I only needed the 3rd. So I did all of this just to make sure that I wasn't going 655 on accident or 652 on accident. I did that, but I didn't write the rest of it. I'm not going to keep it crossed off because if you need it for notes purposes, I'm going to leave it there, but now you understand. So 15x to the 4th. And then negative 2y squared is just negative 2y times negative 2y. Negative times a negative is a positive. 2 times 2 is 4, so times 4y squared. Do the variables matter? Nope, they only want the coefficient. What's 15 times 4? 60. So 60 is my answer. Is your mind blown? I bet it is. All right, let's go ahead and move on to the next problem. This one is so fun. Okay, this is another one for my high school people. We did 2 for my elementary people at the beginning. We're going to do 2 for my high school people right now. -1 plus cosine of theta equals -2 minus the square root of 3 divided by 2. Solve it. Y'all, I love a good trig problem. Okay. -1 plus cosine of theta equals -2 minus the square root of 3 divided by 2. I'm trying to solve for the cosine of theta. So I want to get the cosine of theta by itself. So I'm going to write cosine of theta equals, well, -1 plus -2 minus the square root of 3 divided by 2. Got it? Now, I am going to add 1 to both sides. Makes sense, right? When you don't know what to do, what I do, I mean, it may not be the best strategy, but what I do when I don't know what to do is I just start moving things around. Balancing it, though, if I add 1 to one side, I have to add 1 to the other. If I subtract 1 from one side, I have to subtract 1 from the other. I'm obviously going to balance that out, but I just kind of start moving stuff around and seeing if it works if I really don't know what to do. Okay, let's keep going. So cosine of theta equals -2 minus the square root of 3 over 2 plus 1. Now my brain is like, this is not like a cosine thing. So I don't know what that even, like, what do I do with that? Great question. Now what you're going to do is I am going to split this off. Hey, I just created a trapezoid. I'm going to split this off and see if I can simplify it at all. Because that's the ultimate goal, is to get this cosine to look like something I recognize. Do you want to know why I'm guessing my internal gut is telling me I'm going to see something I recognize? Because I recognize all of these guys. I recognize all of those pi over somethings from the unit circle. So my guess is that this is going to become something I recognize. If this was something I didn't recognize, then this would probably be something I didn't recognize. Are you following me here? Like, use your answer choices to your advantage. When I was solving this problem the other day, I was like, oh my gosh, those are things I recognize. So obviously this is going to be something I recognize. All right, moving on. So I'm going to split that off. Cosine of theta equals -2 divided by 2 minus square root of 3 divided by 2 plus 1. -2 divided by 2 is -1 minus the square root of 3 over 2 plus 1. Hey there, wait a minute. -1 plus 1 is 0. Those cancel out. So I have cosine of theta equals -square root of 3 over 2. That is totally familiar. Woohoo! Now, what do I do with that? Well, now I need to know my unit circle. So here's my unit circle. Elementary and even some of my middle school people are probably like, what in the world are we even doing right now, right? Here's my unit circle. And I know that this is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi, right? And I know that cosine has to equal the square root of 3 over 2. Where does cosine equal a negative value? What quadrant? 2 and 3. Cosine equals a negative value in quadrants 2 and 3. Why? Because cosine is the x value of our coordinate points. Sine is the y value of the coordinate points. And when I look at a graph, the x value of those coordinate points is negative when I'm going to the left, which is quadrant 2 and quadrant 3. So that's where I'm going to get a negative square root of 3 over 2 is 2 or 3. That said, if I draw my 3 angles here, didn't mean to erase. I know my options are square root of 3 over 2 or 1/2 with cosine. So x is going to be square root of 3 over 2 here and here. And if you're not sure why, it's because I've learned the art of interpreting the unit circle. And if you want the art of the unit circle, let me know in the comment box and I can go over that next week. This is less about the art of the unit circle and more about solving this cosine problem. So if you want more art of the unit circle, let me know in the comment box. All that said, here we go. So I know it's this one and this one. So as I count around the unit circle, I have 1 pi over 3, 2 pi over 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. This one is 5 pi over 6, which has to be A or D. I know that pi over 6 is a first quadrant angle, so it has to be A. And then this is 6 pi over 6, and this is 7 pi over 6. Again, if you want the art of the unit circle, just let me know in the comment box, and we can do something a little bit more simpler to go over the unit circle. All right? All righty. We have time for one more. So we have gone over 2 highly requested problems. This is a 3rd requested problem. And like I said, y'all, I had so many requested problems. So if I did not get to your problem tonight, I promise it's on deck for next week. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 9 problems that were requested still on deck, and those will be the ones that we go over next week. All right, the following functions are defined below. F of x equals 3 divided by x minus 4. G of x equals 5x plus 4. And h of x equals 2x squared minus 3x plus 2. Find h of f of 7. All righty. So how do I solve this problem? We have to think of this as a function of x, right? So these are all functions of x, and I'm trying to find h of f of 7. So what am I going to do? I'm going to do inside the parentheses first. So I'm going to do f of 7 first. Whatever I get for that, I'm going to plug in for h of, and then I'm going to solve for that. So I'm going to do f of 7. F of 7 just means, hey, take the x value wherever it is and replace it with a 7. So 3 divided by x minus 4. Hey, take the x value wherever it is and replace it with a 7. So 3 divided by 7 minus 4. 3 divided by 3 is 1. So now I'm going to use the substitution property, literally replace f of 7 in this little doohickey with a 1. So now instead of h of f of 7, now I have h of 1. That's it. So I have h of 1 equals anywhere there is an x, I'm going to replace with a 1. 2 times 1 squared minus 3 times 1 plus 2. 2 times 1, 3 times 1 plus 2. 2 minus 3 plus 2. 2 plus 2 is 4 minus 3 equals 1. That's really funny that f of 7 was 1 and then h of 1 was 1. That's it. That's all. So simple. All right. I told you we were going to cut out just a little bit early today for the holiday weekend. So let me know in the comment box things that you want to see me go over next week. I will absolutely include it. Happy Independence Day. Enjoy the the time with your family, and just being thankful for the country we live in. And make sure that you let me know what you want to see me go over next week, either in the comment box or on our Facebook page. And I look forward to seeing you next week for so many more problems. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.